and the topic I've been given is COVID-19, and the country I've been given is Brazil. So first of all, I like to show how I got the data from. So I head on to the website called Worldometers, which has been designed by my lecturer, and the country I've been given is Brazil. So I just scroll down one of the graphs and I just right click on it and I scroll down to view page source. This shows the coding that has been done behind the graphs. So if I just scroll below, eventually I'll find the data that has been used to plot all of these graphs over here. So for example, I just scroll below and this is the total cases for each day. So the dates are from February 15, 2020 all the way until the last day. So I just, let's say, copy this entire line, copy it, I hit over to Excel. Let's say I paste it in this cell over here, this single cell. So click on it and then paste it. So before pasting it, make sure that I remove the unnecessary words, which is those words, and click on enter. So before that, I have to scroll to the end of the line to remove the unnecessary words there too, but they'll be taking some time, so I'll just skip the part. So once it be listed in a single cell, I separate it with the text to column feature in the data tab. So I use delimited and comma. So once it sees comma in any part of the line, it just splits it in the next column. So once I click next and finish, this is how it would look. So it has all the dates in each column, but this is what I don't want. I want it to be in every row, so I can make a parallel array, right? So to do that, I just select the entire row, copy it, and then go to another cell and transpose it. So I go to paste, special, and then transpose it. Once I transpose it, it looks something like this. So it'd be easier to read compared to the ones in the column just now. So I just delete it. So once that's been done, I go to the specific respective data values. So this is the total cases, and the values for the total cases is the one over here. So just copy everything. Same thing again, go to the cell, paste it, and before I click enter, remove the brackets and the wordings. And I have to do it at the end of the line too, but that'll be taking some time to go to the end of the line. So just click on enter, and then same function called text to columns. Use delimited and separate it to different columns. So this is how it look. And then again, copy it, go to this cell over here, and then transpose it. Once I transpose it, this is how it will look, and I delete the original row. So this is the data I've been extracted for the total cases. The total cases, and if I head down, I have the data for daily new case. And if I head down some more, I can find the data for active cases. And if I go down even further, I can see the data for total deaths. This is the days, and the corresponding values for each day would be the one below. So once I extract it one by one, I would get an Excel file which looks something like this. So for each day and each respective daily new cases, and this is for deaths, daily deaths. And then this is for daily recovery. So data for daily recovery. So this data extends very deep, probably into the row of, I don't know, maybe 2000. So yeah, that's how it looks. And then to get the monthly values for each of the parameters, I just use sum function, for example. So I just click sum. And for example, let's say I want to take the value for June of 2020. I just highlight the entire cell. So I get the total for 2020 June would be 30,342. This is how I did to get the total monthly values for the parameters. And once that's done, so let me explain how I got the other values. So let's head on and go to the explanation of my code. Okay. So the domain that I've been given is between March of 2020 until 31st of December 2023. And the parameters that have been tasked with is total cases, total deaths, and total recovered. So first of all, I created a C++ project and I used hashtag include iostream. So this command allows the use of cin and cr to be valid. And I use hashtag include iomoney. This uses the setBit function. which particularly aligns the table columns, and I used hashtag include fstream, which is used to both read and write files. And I used hashtag include csd library. So this is to execute system commands. In this case, I use it to run the GNU plot script. And then I used hashtag include string, which is to use string operations. And the last is using namespace std, so I can use names of objects and variables from standard library. And this avoids the need to use prefix standard name std cout ... So the first function here is of the type class. So it's called COVID data visualizer, and there's a private there. So inside the private, I have constant int data type, data size. So this stores the data size to be constant, which is 46, and I have below there would be string months 46. So this is actually an array of string type, which has 46 entry points. So the first one would be 2023-03. So this actually represents the month of March 2020, and this goes until the December of 2023. And below that, I have an array of integer data type for total cases. So the first one would be 2312 would be the total cases for the March 2020, and then so on. And same goes to the array of total deaths and total recovered, which has the type of integer. And then the second function is called create data file. This function creates the data file, which is used to plot the graph. And then I have ofstream data file data.dat. So this creates output file called data.dat to write data into the file. And then below that, there is if exclamation data file. So this is if cannot find the file. So if the program cannot find the file, it will output an error message. So that's why I have CERR. This is similar to cout in this case. So I'll put the error message called unable to create data.dat file. And then I have data file.close. So this is to close the output file stream. And then I have a white function called create plot file. So this function creates a GNU plot script, which is used to plot the graph. And then I have ofstream plot file codedata.p. So this creates an output file called codedata.p to write GNU plot script into the file. And then I have if exclamation plot file, and this happens if it cannot find the plot file. And then if it cannot find, it will output an error message, which is a CERR over here, which is similar to cout. And then under there, there's called plot file less than. This is similar to cout, but in this case, it doesn't cout to the console or the user interface terminal, but it actually writes the text into the external file. So this plot file is used to write some text into the external file. And then we have plot file.close. So this is to close the output file string. And then I have a function called run GNU plot. So this function runs GNU plot for the graph, and then under that I have int status equals system GNU plot code data.p. So over here, the integer status takes the value which is written from the function system GNU plot code data.p. So this function system actually returns integer value, 0 indicating success and non-zero value indicating failure. So this function is actually to run the GNU plot to plot the graph using the code file, which is codedata.p. Then I have an if-else statement. So this if-else statement is used to specify a block of code to be executed if a specified condition is true or false. And then I have a public. Inside the public, I have left and right words. So this left and right is not a word, but it's actually a command. So left justifies the output, which means all the output will be pushed towards the left. And once it's right, all the output file will be output words or values will be pushed towards the right. And then I use set with function with set with w and set with 15. So this outputs the value of an expression in a specific number of columns. And I used cout string 55 with dash. So this prints a horizontal line of dashes, which is 55 dash 55 times. And then I have function nline. So this nline function moves the cursor to the beginning of the next line. And then let's move on to the next page. So in this page, I have white function called generate rates. And then I use the word constant over here so that any operation here wouldn't alter the values of the data. And then I have ofstream output file, COVID rates output of text. So this creates an output file called COVID rates output.txt, which is to write data into the file. So if exclamation output file is open, which means if it cannot find the file, it'll output an error message over here, which is the CERR underscore less than error opening output file. And then I initialize and declare the value of month index to be -1. And then I see out the words. So this is for the user to pick a month. So I told the user to select a month with each value representing each month. So one here represents March 2020, two for April 2020, three for May 2020, four for June of 2020, all the way until 46, which is for the December of 2023. So if you look closely at here, the values start from 1 until 46. But if you remember, the index value of an array starts at 0. So in order to make it related month index and the index value of an array, so I just have to minus the month index by 1. So I use month index minus minus. And then I introduce a string called selected month. So this string called selected month would take the respective value of the month which the user wants, which I got from the month index earlier. And then I use same goes to int cases, which takes the total cases using the index value just now. And then same goes to deaths, which takes the value of deaths for the respective month from the array of total deaths. Same goes to recovered. And then I introduce the formula for mortality rate, recovery rate, and case fatality rate. And this function, which has been given to me by my lecturer in the final assignment. And then moving on further, I have the printing results to the console. So this function at the top over here will print results to the console. So the COVID data for the month which the user selected will be below total cases, total deaths recovered, and it sets precision to be 2, which is the number of decimal points. And then the down part, which is output file less than, that will write the words into the external file. And the output file close basically closes the output file stream. And then I have another function called create data file, and it's of the function void, so it doesn't return any values. I use the word constant here so that I don't alter any data type while performing any operations. So the function called create data file bracket, this is basically to call the create plot file function, which creates the no plot script, and then the function called create data file creates the data file, and then the run GNU plot function runs the GNU plot. And then moving down, I have int main, which is the main function. So this main function usually returns an integer value because it's a type integer, and this is where the program execution usually begins. And inside there, I have a COVID data visualizer, space visualizer. So what I did here is just I created an object for the class. So all functionality related to handling the data in the class is encapsulated within this object. And finally, I have written 0. So this explicitly signals successful program execution, and non-zero written values are used to indicate errors or abnormal termination. This is how the output looks like. So the output is pretty long, so just why I separate it into pages. So the page 1 here over here, which represents the month cases, deaths, and recovered for every month. And if I scroll below, it will show data.dat file created successfully, code data.p file created successfully, GNU plot is not recognized as an internal or external command. And this error command is because the directory for GNU plot is different from the directory of the output file that I created in C++. And moving on further, it will ask the user to select a month between March of 2020 until December of 2023, with each value signifying a respective month. So let's say I pick the month which is number 10, which is the December of 2020. So once I click the number 10, the program calculates the total case, total deaths, total recovered, and plugs it into the formula to calculate the mortality rate, recovery rate, and case fatality rate, and puts it on the console. And it also writes the data into an external file called COVID rates output.txt. And therefore, we can read the output file later. This is how the output file looks like. And this is the graph I got from plotting using GNU plot. And then, so this is to justify and compare. So once I head over to the website that's been given to me, so daily new cases, all the graphs on the right is the one that I've obtained from the website, and the one on the right over here is the one that I've plotted myself using GNU plot. So if I look closely over here, the graph provided by the website and the graph plotted by GNU is very similar. And if you look at the trend over here, it's quite evident because it starts closely at 0 and it has like 2 bumps in the left-hand side. So the same signifies over here the first exponential rise and second exponential rise. and followed by the biggest trend upward over here, which is this one, and then a small upward trend on the right hand side. So this is pretty similar to the one that have been obtained by the graphs in the website. So the graph for cases and recovered pretty much matches the one on the website. And the ones on the website doesn't show clearly the total deaths because this total deaths is actually a cumulative value. And therefore, in order to calculate specific total deaths for each month, I have to extract it. So, and there's exponential rise in the debt between the January of 2021 until August of 2021. So if you look at the graph on the left, the bottom left, you'll see there's an exponential rise between the January of 2021 until the August of 2021, which signifies that those months are having the most deaths. And therefore, if you look at the graph, which is plotted by Jenny plot, you'll be seeing the highest value for the deaths are occurring in the same period, which is between January 2021 until August of 2021. And if I go to the next page, so this is the analysis and suggestion from my side. So this on the left is what I've got from my own C++ code. So I think it'd be better to look at the one on the right because the one on the right actually has some extra tables with extra borders. So this displays the code data in a formatted table, making it easy to read and interpret. And the second suggestion is when it asks the user to enter a month. So the one on the left is the one that I actually have in my running code. And the one on the right is a suggestion, which is an improved version. So the one on the right is more easy to read and choose because there's only one option in every single row. So that's it for the explanation of my code. So now I'll be showing how I got the graph, which has been plotted by the GNU plot, the one that I have over here. So in order to get this graph, what I do is I just head on to the GNU plot application. So before I do anything, I have to change the directory because by default, it's always sticking to the documents folder. So before that, I go to the GNU plot directory because that's where my output file that I created is stored. So in order to draw the graph, I just write load code data dot p. So there's no response there, which means the graph has been successfully plotted. So if you look over here in the same directory, this is the plot graph. So this is a similar one that I've been shown earlier. And then moving on from there, let us enter the C++ program and run it. So the code here is pretty much the same thing that I've explained to you part by part in the PDF earlier. So it's basically the same code until the end. So if I compile and run the code, this is how it looks. So I have to scroll to the top so that you look at all of the things. So you have months, cases, deaths, and recovers. These are the parallel arrays over here. So I use the setBit function to properly align it so it looks very nice and neat. And if I go down, you can see that the data.dat file being created successfully, code data.p file created successfully, and the GNU part is not created because of the different directory as I said earlier. And then it asks the user to enter a month for it to calculate the rates. So for example, here, let's pick a new one. So for example, let's say we're gonna pick December of 2020, so which is the value 10, right? So let's pick 10. So this is the code data for December of 2020. So the total cases, total deaths, total recovered, the mortality rate, recovery rate, and the case fatality rate. So this is the output file which has all the values which is written onto it. So if I go to my C++ directory, DB C++, and search for the text file, COVID rates output.txt, so you can see all the data that's in the program which has been written into it. So we have the COVID data for December 2020, total cases, total deaths, total recovered, the mortality rate, and the recovery rate, and the case fatality rate. And therefore, by explaining this ends my explanation for the code. And I would like to say thank you.